Mirrors and Reflection Vocabulary, a 9th grade conceptual physics video. When you look at yourself in a mirror, you see yourself because light from your head and feet are bouncing off the mirror and following the law of reflection. Light from your feet hits the mirror and bounces to your eye. Your feet are not emitting light, they don't glow in the dark, but they are scattering light from the ceiling in all directions. The one ray that hits the mirror and bounces to your eye is the only one we care about right now. Remember the mirror vocabulary? Which one is the ray of incidence? Which one is the ray of reflection? Where is the angle of incidence? Remember, you need to draw a normal. Where's the angle of reflection? Light also comes from the top of your head to your eye, bouncing off the mirror at equal angles. You should be able to prove that the section of the mirror that you need to see your entire body is only half as tall as you are. Hint, use similar triangles. You see yourself in the mirror because your eye is fundamentally limited. Your stupid eye assumes that any light that enters it has always been traveling in a straight line. Your brain knows better, but your eye just assumes that the light came from somewhere off in a straight line path anyway. It's like the ray of incidence swings around and makes a straight line with the ray of reflection. This ray that your eye made up does not really exist. It's only in your mind. No one else can see it. We call this the virtual ray, and we draw it with dotted lines so that it is clear that it only exists in your mind. We draw another continuing the other ray of reflection, because your eye assumes that that one has been going straight all along as well. The light that came from your feet is what you see as your feet. The light that came from your head is what you see as your head. Thus, your image is located between those two virtual rays. Notice that your image is as far behind the mirror as you are in front of it. That is because your eye understands the distance the light has traveled, even if it cannot perceive that the light has reflected. Let's go over the mirror vocabulary on this picture as well. There are two rays of incidence. Where are they? There are two rays of reflection. Where are they? Where are the virtual rays? Virtual rays are always dashed, and they are on the not real side of the mirror. Where's the image? The object is the original, real person. Notice that because of the law of reflection, the points where the rays of the light hit the mirror remain the same. As you back away from the mirror, your image also backs away. Let's say the mirror is too small to see your entire body. How much can you see? The easiest way to figure this out is to draw the lines of light that your eye sees from the top and the bottom of the mirror. You're actually drawing the rays of reflection connected to the virtual rays. Then fill in the rays of incidence later once you know where they're going to hit on the image. This is all you can see of yourself in that small mirror. Now if you back away, no matter how far back you go, the way light travels, you still see the same part of yourself in the mirror. Looking at our old ICU problem, let's talk about finding the image in the mirror. The red person A is looking at person B in the mirror. We know person B can see person A, but that's not what we're showing right now. Point P is where the mirror is. The ray of incidence from the object hits the mirror and bounces to the person seeing things. Then that person's stupid eye continues the ray of reflection backwards and creates a virtual ray and an image. This image, like all images seen inside mirrors, is a virtual image because it is not really there.